समित जी हैं यहाँ पर?
Hi Nitin, I'm here. How are you?
Yeah. So Mr. Samit Soni, he's a very great experience in the ball mill optimization. Even I am learning something from him regarding the ball, how to optimize the ball mill. And presently, he's working in the MAPI as expert. You can also take the guidance if you face any difficulties in your plant in India or anywhere. So over to you, Samit sir. First of all, thank you for giving the time to us because everyone is want to learn about the ball mill part about, and they are very excited. So you over to you.
Thank you, Nitin. Thank you for the introduction. Good morning, guys, or it's good afternoon there. Sorry that was the confusion with me regarding the timing of when to join. But hope you guys are doing good.
Alhamdulillah, sir.
Yeah, great. So I'm Samit Soni. Just a brief introduction about me. I'm a process engineer, chemical engineer by training. I have around 15, 16 years of experience in cement plants or in cement industry. I won't say cement plants. And currently I'm working with MAPE and we supply grinding aids, but since my background is process, I also do a lot of technical audits, consultations for my region. And I'm looking after Middle East and Africa as commercial and technical for now. So ball mills are like something which is a part and parcel of a cement industry. All the grinding depends on it. We all know. So just a quick question: for how many of you guys are actually dealing with ball mill on a day-to-day basis? Because I know with the newer plants, it would be around a lot of plants will be having a lot of VRMs. So it's a good number. It's a good number. It's a good number. Before starting, see, we have all seen a lot of presentations about ball mill audits. To be very honest with you, it always goes in the same loop. Like this is ball mill, this is filling degree, this is that. Do you guys have something in particular which you want to understand so that not in this presentation, but let's say next week I can actually prepare something for those specific topics. Let's say some calculations, some logics about the how to charge the ball, or if you want to understand the separator. You guys can speak. You guys can speak.
Sir,
Uh,
Saurabh Kumar this side, sir. Sir, related to Trump curve means separator efficiency, sir.
Okay. So I can do Trump curve. Yes. Okay. But apart from that,
sir,
on a
related to
day-to-day basis, because see, Trump curve is something which you do once a year. Because even if you do a Trump curve, you cannot go and just change the separator.
sir, related to troubleshooting, we are currently experiencing a problem with our ball mill as we have switched from gray cement to white plant to white. That is, we have converted our gray plant to white plant. So we are having a lot of issues, and we also have placed our query to MEPI, but it is under review. We are having problem of the choking of the first compartment, and it is very prone of every time we have to stop the mill.
Okay. 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 So you are basically having jamming. Okay. So it's basically a flow concept. Okay. Okay. I'll pick these
Diaphragm
things
jam.
then.
Yes, sir. Basically,
Yes.
diaphragm jam. That problem was not with the gray clinker. It has been witnessed a lot of time with the white cement because we have changed from gray to white.
Yeah.
Uh,
So yes, then this is something which needs to be, understood on a step-by-step basis, and then we can go ahead and see. Because when you change from gray to white, the size of the clinker, the fineness, the malleability,
Media also,
grindability.
grinding media also.
Exactly.
Sir,
A lot of things change.
our query is already with MEPI. So if MEPI team solves it, kindly share it in this form as
Who
well
are
for the
you dealing
information
with
of
in
everyone.
Mape?
Sir, I'm currently unaware of the name, but my colleague process engineer has sent the query to
Which
MEPI.
plant is it?
Best Way Cement, Pakistan. Best Way Cement,
Okay.
Farukia plant.
Okay. Perfect. I'll get to it. I'll do that. Thank you. So I understand mostly it is like day-to-day things, jamming, choking, grinding, grindability, all those things. So In the coming days, if Nitin allows me, I'll get to those things as well. Very small, but very concentrated topics. Today, I would
So sorry
just.
to interrupt you, sir. Sorry to interrupt you. One thing more, about the ceramic grinding media as well.
Okay. सब ceramic grinding media से अच्छा है, if you allow me to speak in Hindi as well, in bits and pieces. Um, I have been dealing with white cement grinding for quite a long time right now, and to our experience, why your normal high chrome media also works. You don't have to switch to ceramic grinding media. Ceramic grinding media, I would say, like it's kind of a Rolls Royce thing which won't matter a lot. Okay, the weight changes a bit, there will be a little bit of power saving, but you can still get the same things done by your existing grinding media, which is the iron or the high chrome one. And yes, the color doesn't change. We are using the metal balls. But yeah, we'll get to that as well. So I'll just start my presentation. Perfect. Can you see my screen?
Yeah, it's visible, sir. It's visible.
Yes,
Perfect.
sir.
Visible, sir.
Visual, sir.
Perfect. So let's start by discussing a bit about what is the role of ball mill audit in the cement plant. Like what exactly we get out of it, why we do it. So just stating the obvious things for improving or for optimizing any process in general, we need to follow a three prong step. The first one is data collection. So whenever we have a system in our hand, be it your mills, be it your kiln, be it your plant, be it your house, anything, be it your car, the first step of optimization any system is to collect the data. When we do a ball mill audit, or when we start a ball mill audit, the first thing we start collecting is the basic data of the mill, the length, the dia, the kind of liner it has, the filling degree it is having right now. Okay, all these many small steps. So there is a whole table. If you want, I can also share those things with you eventually. Once we have the data in hand, the next step is to analyze. Analysis of the mill will curtail, let's say, finding the HD ratio. Then, based on that, finding the filling degree. Then, based on finding the filling degree, understanding whether the mill is full or not. In a second process, let's say we'll collect some actual samples. We'll plot them in a graph. We'll do the residues. We'll plot them in a graph. Then we'll try to understand whether the mill is grinding or not, where the grinding is lagging, where the grinding is, where the curve is dipping, where it's going like up. Then we have the samples from the circuit. So we'll put down a tromp curve or a RR curve or a cumulative curve based on the circuit that you're having. So that will help you to analyze how exactly your system is working right now. Now, the third thing will be recommendation. Now, based on your analysis and the data that you have in hand, you will decide what exactly you want to change. You want to change the liners? Do you want to change the diaphragm? Do you want to change your water spray, optimize your water spray, let's say? Do you want to change the ball charge itself? Right. So there have been instances where we have actually, after an audit, we have changed the central mesh of the mill because that wasn't doing the right job, or we have asked the client to increase the length of, let's say, first chamber, or reduce the length of those, or remove the drying chamber completely. So there are those kind of recommendations which you give once you have a clear understanding on what your mill is doing. One thing that I failed to mention here, that when you're actually doing an audit, the first and foremost thing is to understand why you are doing an audit. What are the challenges that you are facing? Once you write down or once you actually bookmark your challenges, that will help you to set the direction for your audit. Let's say, for as an example, we are not getting blane and residue in the mill. So if I'm not getting blane and residue in the mill, my first approach will be the first test that I will do is to see the circuit sample and then go to the grinding mill inlet and outlet sample just to understand the grindability. If I have some certain values from these two analysis, then I can set a stage for the complete audit where I'll do the separator flow balancing, separator flow data collection, then how the mill actual grinding is happening, and so on and so forth. On another round, let's say if you are having a challenge with the workability of the cement, which happens a lot in the Middle East and Middle Eastern region, then we'll have a very different approach. We'll try to understand what is the WK ratio of the cement that we are producing. We'll try to understand the kind of PSD that we are producing. What is your 3 to 32 and what is your 45? And then based on that, we'll see how our actual searing is, how we can optimize it while grinding. And third thing that a lot of people fail to understand is your water spray, which plays a great role in your workability as well. So how we can optimize that as well. So now based on your objectives, we'll set a direction or set a course for the audit in the coming days. And these things, that's why it's very important to first write down why you are doing an audit. Okay, there are monthly audits, biannually audits, uh, 3 months audits that are scheduled. But now and then we need every time when we are going for an audit, we need to know why we are doing it. Just to be very focused on putting the efforts into it. Because moving on to next, why we do an audit, as in like we all know this is basically some numbers of energy consumption in the plant, and if we see the energy consumption for the grinding of cement is almost 50% of the total requirement, 40 to 50%. So, and this, since it is so high, it takes most of the OpEx in terms of energy for the plant. So why not strike there first? If you optimize your grinding, you get to reduce your production cost. You get to produce a good quality of cement, so on and so forth. Okay, good. So as I was explaining earlier, why to do a mill audit? So it gives you obviously a very big picture on how your mill is performing. And once you understand that, obviously that coupled with or your objectives, you can always decide when and where and how to do the audits. If you want to, let's say if you want to go for an expansion, until unless you don't know how your mill is performing, any expansion cannot be justified in terms of number. So moving on to next. Why do we conduct a ball mill audit? Again, I'll be circling across the same topic for some more time, because until unless I have been asked to do an audit for a cement plant or a grinding section, a lot of time when it was not even required, or the client doesn't even know why they want an audit. I'm sorry, someone is raising a hand. Is there a question, Mr. Ram?
Ram, do you have any questions regarding at the end of presentation you can ask. I request everyone they can ask at the end of it.
Okay, okay.
Okay,
Okay, over to you, sir.
I'll continue. I'll continue. So Yeah, what I was saying is I have been asked to do audits of multiple mills where the client never had a visibility on why they want to do a audit or what they are going to get out of the audit. So, as I said, again, it's like a medical checkup for your mill. You have to understand why you're doing it. Once you know that, you have to have a, let's say we start by measuring the vital sign: temperature, pressure, power, vibration. What is working, what is not working. If something is failing, understand why it's failing. Is it electrical fault? Is it an instrumentation fault? Is it a maintenance fault where it had a certain parameter or certain equipment has been neglected for a very long time. Let's say for an example, the most neglected equipment in a cement ball mill over a period of time when the mill gets older is the phone. A lot of time people place it in the wrong direction to start, as for starters. Even if they, let's say, even if the supplier has done a good job in placing it in the right direction, right space, 4 o'clock degree, and all those things, they still, over a period of time, it stops working, or it gives you wrong reading. But mill operator or the process engineer, just because of the sheer overconfidence of, yeah, we know this mill and how it works, and we have been running it for so long, they start neglecting the fuller phone as such. The readings are, I have seen readings of 180% in fuller phone, which is obviously not the correct thing. So equipment like these, which actually give you the on-time picture, the real-time picture of your mill, gets neglected over time. And that is the reason why when we are measuring the vital signs, we have to identify what is working, what is not working, and why it's failing, as I mentioned. Now, once we have that, we build a knowledge base. We do one audit, we know, okay, what is the real-time situation of the mill. When we start doing the audit every 3 months, every 6 months, we start collecting data that is based on time. You have your data of your cement production. You can correlate your numbers. You can correlate your wear rate. You can correlate your amount of cement versus certain parameters, and you get to have a trend. Now, there's one challenge I would like to mention here, which a lot of people who are grinding GGBFS in a ball mill phase is they start with, let's say, a feed of X, and obviously the feed of X is anyway 50% lower than the installed capacity of the ball mill. So let's say the installed capacity is 100 TPH, and the cement, when you switch from cement to GGBFS, the TPH of the ball mill goes directly to 50. Now, considering the kind of wear a GGB or slag can do, that 50 TPH falls down to 30-35 TPH within a period of 6 months. And the process engineer, the production manager, the plant manager, they are scratching their head in terms of like why it was doing so much. Now it is only doing this much. On the top of that, I'm not saying they don't relate with the numbers. They do relate with the numbers, but the numbers are never realistic, because the numbers that they are relating to most of the time is a number for cement. Again, this is a case-to-case scenario, but I'm just talking out of my experience. So when you're comparing something with some number which is based on the cement grinding, obviously it is not going to work with the GGBFS or SRC grinding, or PLC or grinding, or post-donor grinding, let's say. So this multiple audits will give you a trend on the performance of the mill. We understand how the mill behaves with different clinkers, different raw materials, different kind of fillers, let's say, because, for example, in Jordan, they use a kind of pozzolana, which is, I think it should be somewhere close to diamond. It's very hard. It's very hard to grind. It's very abrasive. But since the consumer mindset is that they want to have a black color cement, the cement plants in Jordan are bound to use this kind of filler. So they do have limestone as well, but limestone really like makes the cement a more whitish. This pozzolana makes the cement more blackish. So now we have to understand that how that kind of filler is also behaving with your raw mill. Once we have these trends, then after a certain period of time, we become adept to our mill. We start knowing it, and then we can also at least predict the problems or do a pre-maintenance, what you say, a preventive maintenance to make sure the running is consistent. Now, the third objective is usually to identify the strengths and weaknesses. We create specific recommendations. As I mentioned earlier, also, we need to know why we are doing it. If we know why we are doing it, we can always say what we want to do to fix it. Rather than just running an audit, collecting samples, calculating the size of the balls. That has happened as well. I've conducted certain audits in certain places where from where I never received even the data. So instead of doing that, if we know why we are doing it, it's always helps. And obviously, it helps you to set timelines for the implementation because then you know based on the trend that when I will be reaching to the next point of time where I'll have to conduct another audit or another maintenance. The fourth objective is obviously to develop an actionable plan. Based on all that we have discussed up till now, the synapses would be this is what I want to achieve, this is what the challenge is, and this is the timeline to do it, and that's the action plan to do it. And it would be a very realistic action plan in that case. So again, same thing. How healthy is my mill? What do I need to know? What's working, what's not working, and what do I do next? And this is a vicious cycle which goes on and on and on and on. It stops there. Obviously, when we are deciding to go inside the mill, I would like to talk something about the safety as well, which we are actually going into a high temperature environment, not safe. We have to make sure that the main motor is the power is excluded, auxiliary is excluded. No, in no certain way the mill can be rotated. People know that we are inside the mill. All the main motors, the way feeders are excluded, there the power is off. The dynamic separator motor is off. There is a tag, lock and tag there. All the fuses of the all the fuses should be removed. As simple as that. If there is ways to exclude in other ways, why not? Once we exclude it, the owner of the audit should appoint someone who should have the responsibility of making sure it is logged, tagged and logged, and it is in his possession until the audit is over. Until the samples are collected, they are taken out of the mill. All the equipments of collection have been taken out of the mill. The sieves have been taken out of the mill. There is no plastic bag left inside the mill. Not a single shoe should be inside. That's his responsibility to do. They are usually the HSE guys. Now, audit prerequisites. Any questions till now? The speed is okay. You guys can hear me?
Okay, okay, sir. Okay.
Perfect. Now, the audit prerequisites. What we need to run the audit. We just can't decide okay, tomorrow we need to do an audit. Let's stop the mill at 12 midnight and get inside the mill at 6 a.m. We need to have a synopsis of the mill operation before. Usually, what I ask the client is for a 2 week log sheet. I study the trend myself, and when the on the day of the audit, we based on that 2 weeks data, we ask the client to run the mill for 6 to 10 hours, let's say, at a consistent feed rate, constant separator speed, consistent product quality, no product change, no switching from OPC to PLC to SRC, and no operator adjust. The not I can't say no, but the least operator adjustments during this 10 hours. So we try to put the clinker from the same silo. Extraction will be from the same silo. No changes there. Usually fresh clinker. The gypsum quality won't be changed. If they're using chemical, use chemical. If they're using natural, use natural. No mixing or whatever. It should be consistent. So that is the first prerequisite. Then obviously, where on which type of cement you want to run the audit. Usually we do it for the cement type which is the most produced one, which is the most selling cement. So let's say in our market we sell 42.5 OPC, the max. So when we are going for an audit, we ask the client, let's do the blank, let's do the or stable operation with that cement so that we know that where what we have to optimize. Right. There are cases when plants wants to do an audit for a slag grinding. They want to they want to understand why and how they can not why how they can improve the slag production in the mill. Then obviously in certain cases we ask them to grind GGBFS only for 6 to 10 hours. Or if they want to start some other composition, or if they want to change. There have been specific requests from certain plants that they want to increase the blane and reduce the residue of the cement from the current without doing a lot of things. We're using the process actually. So that's a very specific request. We know, okay, what is their right now, what is their residue right now, what is the PSD right now, and that what is the target. So choosing the right cement type is also very important. The third prerequisite is usually the information sheet. The information required to run the calculations are very specific and can only be taken from a plant if the plant has a database since the inception of plant. What I mean here is the plant should know the specifications of ball charge that they're using. They should know the type of liners they have installed. They should know the type of diaphragms that they have installed. They should know what is their the amount of water that is going inside the mill. They should have a flow meter there, basically. So on and so forth. So if these datas are there, it's much easier to get to the right numbers by calculation. The fourth requisite is always verify all the instruments, and that is also a part of audit. We do check all the equipments telling you the pressure, telling you the temperature, telling you the vibration. The data has to be verified for all such sensors and it should be calibrated if not. Wayfeeders should be calibrated. Power meter should always be verified. So for the when we are running the first 6 to 10 hours of operation as a stable operation, we also ask the plant to take hourly power counters for the main drive, for the separator drive, for the auxiliary, the way they have segregated obviously in the LC. But we do ask them to get those numbers as well. Because that will help me to cross verify the power that we are seeing in the DCS against the power that we are seeing in the LC load center. Fifth prerequisite is We need to identify all the sampling point and we need to identify all the flow measurement points as well. Cement grinding, when it comes to cement grinding, especially the ball mills, there is no set parameter of putting down the ducts. Right? There are instances where the mill outlet duct goes right away into the separator. There will be a span of, let's say, 5-6 meter. Then from the top of the separator, it enters to the back filter right away, or if it is going through a fan. But all those things, because of the space constraint, because of the optimization of the cost optimization that the product supplier, the mill supplier wanted to do, we don't have a lot of spaces in a lot of time to correct to measure the flow of the air in the ball mill section. So before jumping onto the audit train, we need to identify from where we can take the flow. If not, what are my parameters from which I can back calculate the flow? Using obviously the thumb rules, but there are ways to back calculate based on this. Say, if you can't collect the flow data for in between separator and back filter or mill and separator, we need to understand that, okay, which is the fan which is in the circuit, how we can take the flow of the fan, what will my pressure drop across the back filter if I need to understand the flow across the separator as well. So these things need to be in place before you start the audit. Obviously, sampling locations. Sampling is something which we all know in our circuits where they are. Good. So moving on to the schedule of audit, the next slide. When we start an audit, when we are starting an audit, there are certain there's a certain timeline which we need to follow. So before, let's say, and that starts 6 to 8 hours, before the running of actual audit. We run the mills table, we collect the data. Before the shutdown, 2 hours prior to that, we visit the control room. We see what's going on in last 24 hours, how the trend was, what's the alarms, was there any temperature alarm, was there any vibration alarm, so on and so forth. Was the mill seal working properly? Is the temperature of mill seal working properly? What's the mill cement temperature, mill outlet cement temperature? All those things we need to understand. Current feed parameters, speed of a separator, fans. Has there been a big change in the fan speed or the separator speed? That then we go around the mill. We actually note down the points where we can see that there is a leakage or a false air entering. Let's say not leakage, a false air entering. We identify the points from where the cement is leaking, let's say, and where the spillage. So all those things we need to understand. Leaks, vibration, hotspot, blockages, all those things. Once we have identified those things, once we have noted down all those things, we decide to stop the mill and then wait for the cooling of the mill. Moving on, the mill is cool. We go in, we do the lockout, tag out, and we go inside the mill. And we start the most basic exercise of taking the actual sample. We take the samples, we measure the free height, we take other measurements, H, D, PD. We collect the ball samples if you're doing the piece weight analysis. And we obviously take the photos before entering the mill, after entering the mill from the top, just to understand the level of the material. Once that data is collected, we start the mill, we stabilize it, and we start taking samples from the belt, from the circuit. Now, the feeds, these samples can be either taken prior to the shutdown of the mill or after the shutdown of the mill as well. I recommend prior to the stoppage of the mill. So we take the circuit samples as well when we are doing the walkthrough of the circuit. We can take the circuit sample, we can take the samples from the wave feeder because we need to understand the granulometry. We also measure the airflow across the circuit and we record the operating parameter. Once all these things is done, this is 1 day job. Once this is done, then we take the samples to the lab. We ask them to do the analysis. If we are doing a piece weight analysis, we ask them to check the size of the balls, die of the balls. Once that is done, it takes a couple of days to do the calculations and draw the curves. So in totality, if you're talking about a time duration of a ball mill audit, it takes somewhere close to a week to to finish off all the calculations to make sure that we have done all the analysis and the recommendation based on that. Moving on, when we do a mill audit, internal visit, obviously. So the minute that when we are entering the mill, the first thing that we see is the level of ball charge, the level of material on top of ball charge, the maintenance state of the mechanical state of the mill, obviously. Is there a liner that is hanging? Is the diaphragm clean? Is it choked? Is it broken? So on and so forth. Once we are in, we do calculate, we do measure the length, breadth of the mill and all those things. Now, optimum material level in chamber one. This chamber one and chamber two. Now, this is a parameter which tells you exactly which gives you a first hand review of the mill just by looking at it. The minute you enter the mill, let's say first chamber, and if you see that you can all the balls are visible, 90% of your top balls are visible, and there's not a lot of material next to the diaphragm, it's obviously not in a very good state of grinding. In the juxtaposition, if the balls are completely covered, you can't see a single ball and there's a lot of material in the mill, that's also not a very good case because then your mill is not grinding. It's being suffocated. Same thing in the second chamber. If you go, over the minute you enter the second chamber and you see the level of the material on the top of the wall, it should be somewhere around 40 to 50 mm on the top of the wall. If it is around 50 mm, it's the perfect condition. Your mill is getting the right amount of feed. It is doing the right kind of grinding. The first chamber is doing the right kind of grinding. Your diaphragm is doing good. There is no jamming. There is no choking, nothing. If it is less than that, if you can see the balls, either your first chamber is not working, it's not grinding enough. Second is that you're not providing enough feed to the mill. You can go higher on your feed. Or your flow across of air across the mill is very high, which is taking away the material. These three things. If it is more than 50 mm, you're obviously choking the mill. Now, when I talk about a mill audit, when I decide to do a mill audit, we don't go all ballistic on the mill. We don't, I never advise to do all the analysis that is written in the book. Don't do a piece fit every time. Don't do a complete flow measurement right at the first step. Very practically, I would advise two or three things to understand the mill and see what needs to be fixed. These three measurements that you can see on the screen right now that can give you 80% of your answers. what is your free height of the inside the mill? That will tell you the filling degree inside the mill. It's very easy. You just take a tape, put it on the material, go to the top of the mill, see how much is the height. Second thing, again, filling ratio based on voids. If your ball charge is expanded or if it's not expanded, that will also tell you how your mill is operating. The third thing will be the third exercise is axial sampling. When you do the axial sampling, the residue trend, you get to understand how your mill is grinding across the length. Let's say, for example, we have a thumb rule where the plane of the first meter of the ball mill mm, and the plane of the last of the second chamber, the difference should be around 1000. If it is not 1000, if it's any less than 1000, then the mill is not grinding appropriately, and we need to look at the ball charge. Oh, so if it is higher than 1000, then the mill is actually mill needs more feed. It can accommodate more feed. We do understand the liner wear by doing free height, filling ratio, action sampling. We understand the ball charge optimization. Based on that, we can always define the air swept efficiency and the mill productivity. So I'll go to the first, sorry. So I'll go to the first measurement and we'll discuss a bit on that right now. So what do you need for this measurement? You just need a tape and that's it. You access to the mill door during the shutdown. You go inside and you just measure the free height. That's the distance from the top of the ball charge to the top of the liner or your reference point. It's usually the top of the liner. The middle part of the liner where the wave is in the middle. So you don't measure at the highest point of the wave. You don't measure at the lowest point of the wave, somewhere in between, if that allows. Let's say if your perpendicular direction hits the wave, top of the wave, then you make sure that you measure all across the length of the mill on the top of the wave, on the liner. This is the most basic confusion people have usually. Now, once you have done that, you will measure the internal diameter of the mill and you will divide the free height by the internal diameter to get the h by de. Now, when you have the h by de ratio, you can use this table, which is, I think, available everywhere, to determine what is your filling percentage. Rule of thumb, if it is below 28, it's not adequate. If it is more than 35, your mill is choked. So once you do this, you have the first picture of the mill that whether my filling is optimum or not. If not, in the later steps, you can understand why. If it is overly filled, you can always decide to. You can see if there's material, ungrounded material stuck between the balls in the voids. That can be one reason why your ball charge is expanded and your filling degree is less. Or you have just put in a lot of material or balls, grinding media. So this is where we discuss the. Moving on, we go to the second measurement. That is the optimum filling ratio. Optimum filling ratio is obviously the volume of material in the mill divided by the volume of voids on the ball charge. U value is just basically a fancy way of asking a simple question. How much material is inside the mill compared to how much empty space exists between the balls? The formula is there on the screen, but I would Explain it in a much more layman terms. Explain you have a jar full of tennis balls. Even though the jar looks, it looks full, there's a lot of empty spaces in between the balls, right? And that empty space is void. In terms of mill, it's almost around 40% of volume is void space. Now, let's say you're pouring sand into that jar of tennis balls. The sand will obviously fill the voids in between, right? The U value is simply the volume of sand divided by the volume of voids. So if your filling is 100%, the voids are exactly full, it's packed. If it's 50%, the voids are only halfway full. And if it is 150, there is so much sand that the tennis balls are floating in it, obviously. It's useless. For a ball mill, the filling degree is the filling optimum filling ratio is usually at 90. We accept somewhere in between 60 to 80 is also a good number. Now, if we look at the picture, if it is less than 60, the voids will be empty. The balls are just grinding against each other. So you will hear a lot of noise. A lot of the phone will be very high, let's say, in terms of operation. But the mill will be wasting that energy grinding steel against steel, basically. Nothing else is happening. The productivity will be low. The material grinding will be very fine, obviously, because it's not optimum and not sound. If it is in the middle, the U is around 90, let's say, the voids are perfectly filled. The material is between the balls and the balls are grinding the material. There's an optimal level where you will be listening a very low rumble and it's a good sound. When it is more than 110, there will be so much material in the balls that the balls will literally be floating. The material will be acting as a cushion. And when the balls fall, they hit the material, not the other balls. So when they hit the material, there's no grinding happening. For the grinding, the compact attraction, the material has to be in between the balls and the impact should be there. If it is filled, the impact energy is absorbed and obviously the grinding will drop. Okay, now let's discuss a practical way to check the filling U value during a crash stop. In chamber 1, the first compartment, the material level should be below the ball level, which we have already discussed. And obviously in second chamber, it should be 50 millimeters above the balls. Moving on, the third measurement, which is the axial sampling. We will be discussing this quite a bit. And this is the most powerful tool for estimating the efficiency of any ball mill grinding. This will be basically an X-ray of your mill, telling you exactly where the grinding is happening, at what meter the grinding is happening, and at what meter the grinding is not happening. Now, what you do is basically during the shutdown, we stop the mill. As you can see in the picture, we'll stop the mill. We'll go inside with the sample collection packets. We'll go inside with the people, and we start taking every 1 meter along the length. We start taking sample. And there is a way to take the sample as well. You remove the balls, make sure that you are at least 10 to 12 inches below the level, and then you start taking the samples. You take the samples from three parts. So basically, if you consider this as a cross section of area, the mill, over the every meter you take three samples, and over the length of the mill you take
Yeah, Samir sir,
samples from.
you have to ask them ki whether they know crest stop or not, how to do the crest stop. You have to ask them, the participants.
That's a wonderful question. I actually assumed that. Guys, what are your thoughts? Have you guys ever done a crash stop? Or like how frequently you guys do it? If you do.
Sir, by doing main type local stop or parallelly vent fan, mill vent fan stop, sir.
Yeah. But what is the frequency of crash stops you do every year
Frequency,
for analysis
no, it
purpose?
is analysis purpose, yes, sir. Or if mill is not performing, na sir, after that we will crash stop, sir. If performing is good, it is not need, sir.
Obviously. No, it is required even if it is performing. I wouldn't say that you don't do a crash stop if the mill is performing, because if it is performing, it is your perception that it is performing. It can do better. So it's always
No,
a 6 months thing. You should do a crash stop every 6 months to understand how your mill is behaving.
yes.
Okay, perfect.
But we are
So
not practicing like that.
you should. It's a good thing because then you get to understand your limitations of the mill in terms of, okay, let's take an example. We have a Christian 5 mill. You're doing around 80 tons per hour with a blend of 3,200, 7% residue. That is January
Yes, sir.
1st, right? And I'll consider that you are somewhere in let's say I'll consider you are in India. Now, January is a good month. February is a good month. Come April is a good month. May goes its dry season. There is no much change in the clinker. There is no much change in the raw material. Goes well. Now you are gearing up for June, which is the monsoon, right? Now the first question. From 1st of January, where you were doing 80 tons per hour, to 31st of May, are you still doing 80 tons per hour at 3,208% residue?
No, sir.
Can be possible, right? There will be a change. There will be a wear rate going inside the mill. So come June, it's a very good reason. They have a very good reason to actually do a crash stop, to do a mill audit, to understand the grindability of the mill, because you will be able to foresee what you have to do in the rainy season, how you should change or how you can change your operating parameters in the rainy season, first of all. Second thing is, from 80 to 72, what has changed? Because the mill of TPH will reduce. Let's say it has gone down from 80 to 72. What has changed in the mill, which I knew during my crash stop in January 1st, that okay, I did a crash stop on first week of January. This was the status of the mill. This was the filling degree. This was the piece weight analysis. All those things I know now. Come 31st of May, what has changed in my mill? If you do that analysis again on 31st, you will be able to understand that your mill is what has changed in the mill. Now, being very overconfident here, what I will say is that your mill was running at 80 TPH on January 1st. Your mill is still running at 80 TPH in 31st of May. 5 months gone. If nothing has changed in terms of production, there is something very wrong in the mill in that case. Not in the mill, actually, in the operation. There is a leverage where you can increase the mill feed from 80 to 85, 90, let's say, which you have not been using from last 5 months. So if you do that crash stop, if you do that analysis, you'll also get to understand that how come I'm running at 80? Can I increase more? I should have gone to 90 in January 1st to achieve 80 in 31st of May. So you understand the concept where I'm going, right? You understand the chain of thought where I'm going.
Yes, sir.
So that's why it's
Yes,
important. It's imperative that you do it every couple of months to be on the top of your operating parameters. Nowadays, there's the concept. Okay, just a question out of box, but how many of you are using AI to manage your mill data or manage your plant data on a day-to-day basis?
Not using, sir.
Anyone? Okay. So this is that artificial intelligence is also a very powerful tool. I will take a section session on that as well sometime if time permits. But AI is also very powerful tool to analyze your day-to-day operation and correlate your day-to-day operation with the quality parameters and your last audit or flow measurement. So now I'll take it to a bit a more broader sense. Uh, we have the pyro section, we have the raw mill grinding section, we have the pyro section, then we have the cooler section, then we have a grinding section. You can start using AI, using data analysis. You can actually start correlating your day-to-day data of quality, receivables, the chemical analysis, physical analysis, what is your RR, return dust, and all those things, all those parameters, temperature profiles, with the quality parameters and the mill operating parameters. Once you start doing that, you will start creating a database of your plant in a way that everything correlates to everything else. And believe me, there is a relationship between any data and every data. If your temperature across, let's say in your preheater, if your temperature is going up, right, in your नितिन क्या बोलते हैं उसको स्मोक चैम्बर राइट जहाँ पे आपका एल्कली वो करता है लिक्विड गैस इस फॉर्म में चेंज होता है yeah
Yes,
I think
sir.
it's smoke chamber. So if if you are facing challenges, if you're getting coating, let's say in your smoke chamber, pardon me guys, I'm not a lot in touch with pyro section from quite a long years because obviously that's not my area of expertise these days. I did work. So let's say if you're facing a lot of if you've started facing a lot of coatings in your smoke chamber, on the top of your smoke chamber, let's say, if you are collecting this data, if you're correlating this data, you will obviously get to understand that, yeah, there might be alkali surge in my chromie, right? Or there must be a shift in temperature. We do take a temperature profile of the preheater every now and then. So those data, if you start building up, AI will help you to correlate all that data and to understand your plant operation better. It will also give you where and how you can do the necessary modification and changes. It's just you have to train the model first. So just as an exercise, try and start learning about it. It's very helpful. To be very honest, I do it most of the time. I don't have time to uh, process all the data every time. I do use AI. I've got my own models. So this is something which you can do in your, you guys are in plant. Most of your process engineers, I believe, you are in general shifts. Now you don't have a 8 hour, 10 hour job every day. You can take 30 minutes, understand the prompt engineering, understand the way AI works and how it can, help you to concise your data. Okay, moving on. Moving on. So I'll again go back to action sampling. So now when we take these measurements, when we take these three samples in across the length of the mill, we bag them, we send it to the quality department, and we ask them to do analysis. We'll ask them to run the analysis at 200 micron, 500 micron, 90 micron, 45 micron, 20 mm, 10 mm, all the numbers we'll do. Once we have that, so we'll have something, a graph, we can produce a graph like this. So now in this graph, if you see, you have the data for 5 mm, sieve analysis for 5 mm, 2.36 mm, 1.18, 850 micron, 600 micron, 300 micron, 212, 150, 90, 45. What this means, okay, I've got a trend. Let's say I will exclude the graph at 45 micron or 90 micron. Let's do it 45. So we will remove all these lines and all the other lines, and we'll just see the green line here. If I take this line, what I can see, it's gradually reducing, but at this end it started increasing, which is not a very good indication. Let's say in the second chamber, my graph is going down and suddenly it goes up, and or it flatlines. So this flatlines here, let's say for another 3 meter. That means that obviously my grinding is not happening here. So nonetheless, every data is different. Every mill action analysis is different. So whenever we do that analysis, we see the graph and we understand where we have the flat spots and where we have the spikes. Just let's say, as I was mentioning, no, if let's say if you have a flat spot between 4 to 6 meter, that means there's no grinding happening in that zone. What can be the reason? The first reason will be that your balls are worn out, or there is a buildup happening in the diaphragm slots, or there is a coating that is happening on the balls, that so on and so forth. What if there is a spike? What if your residue goes up? And that it is the very obvious reason will be there's an accumulation of coarse material happening. It's not moving ahead. If not moving ahead, that means it's not flowing. Because it's not most of the time, it's either the diaphragm that is jammed or the airflow across the mill is not proper, or there might be a separator dump or something. Right. But as thumb rule, we have some values which we adhere to when we are judging a actual sampling. So for example, for first chamber, what we see is at 2.5 mm sieve size, the value should always be less than 5%. If it is more than 5%, my grinding is not happening there. So this is one thumb rule which I go with. And this is at the first chamber at the diaphragm. The location of this sample should be first chamber end at the diaphragm. We also measure for 1.5 mm and 0.2 mm. These are the values. For the second chamber, again, at 0.5 mm, it should not be more than 5%. Same location. Now,
Samir sir, actually, in the intermediate diaphragm, suppose anyone can go and want to take the key whether grinding is okay. So generally, what is the thumb rule key? What residue we have to get at the intermediate diaphragm on
so
45 micron?
45 micron, there is no number for 45 micron because
Hmm.
the material is still very coarse at the first chamber. So we don't do 45 micron. We go ahead with 2.5 mm sieve in the first chamber.
No, but in the this intermediate diaphragm, okay, whatever the C size is, you're talking about the first chamber at
Huh.
2.5 mm target value less than 5%.
Less than
So
5%.
it's
Yeah.
mainly at which meter? At intermediate or
Intermediate diaphragm.
it's okay.
This is for the first chamber at the intermediate diaphragm, just at the intermediate diaphragm. So what we do, we start removing the balls next to the intermediate diaphragm, and we remove a good 1 feet, almost 12 to 14 inches we remove. Then we pick up the sample next to the wall of the diaphragm. A lot of time, what people do, they just start removing balls and they take the sample slightly away from the diaphragm. That is also not correct. It should hit the diaphragm. Reason being, your diaphragm has got slots, which allows the material to go inside the diaphragm, swipe and swoop across to the next chamber. So that is where your barrier is. So you have to check what is next to the barrier, not a meter or 50 mm, 500, half a meter away from it. Similarly, for the second chamber at the diaphragm, you should check the 0.5 mm. But when it comes to second chamber, I usually trust the blane, the difference of blane at the end of the mill and at the first sample. That's more better guiding value. It's more global because then we are actually taking the whole mill into consideration. Sorry. Okay, we have taken all the numbers, we have taken the actual saving and all those things now. And where we reach is how we design the boil charge. I will not dwell. Okay, in the next slides I'll dwell at these things as well. But this is just a snapshot on how we do the maximum, how we determine the maximum ball size of the going into the first chamber and second chamber. We have our famous bond formula, work index calculation to calculate the maximum diameter. Usually we take the mill inner diameter, the K factor is usually a constant, 350. We consider the RPM and the critical speed is calculated based on the mill RPM. And we use that for in this calculation. Along with that, we also take the granulometry of the raw material that is going into the mill. And we consider the bond index based on the various raw material. Let's say for limestone, we have taken 10.18. Clinker, we are taking 13.49. And so on and so forth. It's a simple Excel sheet, but it is very crucial to start when you're starting your ball charge design. The maximum ball charge will typically represent around 10 to 20% of the total charge by weight. So when you're taking when you're calculating the D max, that will be around 10 to 20% of your total weight of the ball charge. You will need you will need a gradation of a smaller balls below the maximum size, which will be for chapter 1. Let's say if you're taking the first gradation will be 40% of the maximum size, 30% next size down, 20% again next size down, and 10% of the smallest. This is for chamber 1. Moving on to ball charge design. How much time it has been? Guys, you guys are comfortable or you want to do this in the next presentation? Hello?
Comfortable, sir.
Sir, time हो गया ना इसलिए I was asking
Comfortable,
because ठीक है.
Actually,
but
ball mill
lunch
chart is
time is over.
Sorry?
लंच टाइम ओवर हो रहा है तो 15-20 मिनट और हो सकता है.
If you have 15 minutes, Nitin, let's do this in the next one because it is a
Yeah,
long
yeah.
one.
Okay, so now still time 5 minutes we have to give for this question answer. And what we
Yes,
have to do
please.
next Saturday again, we have to organize this class, okay, in which you can also come with so many questions because and whatever about this class. So you have any doubt? If anyone have any doubt regarding this, whatever he self discussed, because today he's discussed so many things about the this crest top and how to do the sampling. What are the because these are the very important things. If you able don't know how to do the sampling, because sampling, if you're not able to do how to do correct sampling, then you are not able to analyze the this chamber sampling analysis then. Because depending upon the chamber sampling, you have to finalize how much grinding media you have to put in the mill. So if anyone have any doubt, they can ask.
हेलो,
Yes, please.
मेरे एक क्वेश्चन है.
Go ahead.
हेलो,
हाँ जी, go ahead, please. Hi, Rohit.
वॉल्यूम थोड़ा कम आ रहा है. आप
Hi,
सुन पा रहे
Rohit,
हैं
I can
मुझको?
hear you.
सर मेरा क्वेश्चन है सर, जो मेरा एक बॉल मिल है डबल चैम्बर, और उसमें उसके पास सेपरेटर लगा है, तो जो ओसिपा का जो रिजेक्ट आता है उसमें जो मेरा रेजिड्यू है 45 पे अराउंड 50% आ रहा है.
Reject का residue at 45,
हाँ हाँ.
around
तो
50%.
उसका रीजन सर क्या हो सकता है? दूसरा जो मेरा फैन है वो मटेरियल को लिफ्ट नहीं कर रहा सर, जो रिजेक्ट आ रहा है वो करीब अराउंड 400 टाइम्स आ रहा है फीड के।
रिजेक्ट कितना आ रहा है? हाउ मच इज
400
योर फीड, हाउ
टाइम्स।
मच इज योर रिजेक्ट?
तो फीड अराउंड 120
ओके,
और रिजेक्ट कम अराउंड 400 टाइम्स।
400 times?
टाइम्स अराउंड टू फीड।
So your reject is 400 tons per hour.
नहीं, टन नहीं सर, टन नहीं सर, परसेंटेज, परसेंट।
4 टाइम्स आ
400
रहा
per,
है फ्रेश फीड का।
हाँ, 4 टाइम्स आ रहा है, और जो मेरा
हाँ
रिजेक्ट जो मटेरियल आ
480,
रहा है, हाँ
480 है।
480। और दूसरा
हाँ
जो मेरा रिजेक्ट में मटेरियल आ रहा है वो 45% माइक्रोन पे 50% आ रहा है ओनली। तो उसके रीजन सर क्या हो सकता है?
देखो, as a thumb rule ना, your reject should be around 120 maximum, it should be around 220. It should not go more than 250 to 300. ठीक है? So the first thing will be कि okay, another question before I answer this is what is your residue at the mill outlet?
मिल आउटलेट जो 45 पे 30% 45 माइक्रोन पे।
30% at 45 micron. So that is also slightly high. Not very high, but slightly high. Residue? Sorry, blame?
प्लेन 182 210।
ठीक. Then is okay. So then in this case, no, there is a bypass which is happening in the separator.
ओके।
The best thing is you calculate the separator balance. Okay. And once you have your separator balance, do an analysis at 45 micron. Don't do it in, if you, do you have a PSD?
No, radio machine not working in my plant.
पीएचडी नहीं है, चलो कुछ नहीं होता। अगर पीएचडी नहीं है ना तो 90 45 2 1 12।
वो
अगर
तो सर,
63 है
वो तो मतलब डेली बेसिस पे चेक करता ही हूँ। मेरे सिर्फ क्वेश्चन ये है कि जो मेरा सेपरेटर फैन है वो लिफ्ट नहीं कर रहा है मटेरियल। अगर फाइन मटेरियल उसको लिफ्ट करना चाहिए, वो लिफ्ट नहीं
हाँ
कर रहा है उसको।
हाँ,
क्योंकि अब मतलब
बट
45 माइक्रोन पे 50% रेसिड्यू आ रहा है कोर्स से, मतलब कि फाइन्स ज्यादा है, कोर्स कम है। उस फाइन्स को लिफ्ट करना चाहिए फैन को, पर उसको लिफ्ट नहीं कर रहा है। उसके इसमें मेरा फीड नहीं बढ़ पा रहा है मील का।
हाँ,
तो मेरा रहता है इशू, फैन में इशू है, क्योंकि फैन का जो मेरा फ्लो भी अप्रोक्स ठीक है आ रहा है। 1,90,000 का फ्लो है वो मुझको मिल रहा है। और उसके जब भी मेरा जो है मटेरियल लिफ्ट नहीं हो रहा है फैन से।
120 है ना आपके फीट? 1583 मीटर के ऊपर टन।
सर
फ्लो
वन लैख
बहुत
नाइन्टी
कम तो नहीं
थाउजेंड
है भाई? हम्म।
फ्लो तो
नहीं,
वन
पर
लैख
टन,
नाइन्टी
पर टन। आई एम कैलकुलेटिंग पर टन। योर फीड इज 120 ना, तो 190,
ये सर।
190 सॉरी, तो आपका 100 नहीं, your reject is 480, so 480 plus
वन
120,
ट्वेंटी
600,
यस सर।
316
यस सर।
across separator, which is less. यार ये ना बहुत ही क्लासिक केस है। सेपरेटर फैन मार्जिन है आपके पास बढ़ाने का?
नहीं सर, वो फुल आरपीएम में रनिंग है सर।
फुल आरपीएम में रहेंगे। और प्रोडक्ट का वो क्या है आपका?
रेसिड्यू
रेसिड्यू 45।
45 अराउंड सर 16 टू सर 18।
Here, what I would say, na, you cannot do anything on the fan. Let's say, let's assume you cannot change the fan, है ना?
यस सर।
There is no way. OPEX लगेगा, CAPEX लगेगा, OPEX लगेगा, जो आदमी नहीं डालना चाहता बहुत जल्दी।
इससे मेरा क्वेश्चन है कि किस प्रॉब्लम, मतलब किस पॉइंट को मुझे फाइंड आउट करना है जिससे ये प्रॉब्लम क्रिएट हो रही है, वो मुझको जरा फाइंड करना था।
मैं उसी पे आ रहा हूँ,
Sir,
उसी
is
पे
that
आ रहा हूँ।
any mill inlet spillage is happening, or did you check this clinker wave feeder calibration?
वो सब ओके है, वो तो मैं मतलब मंथ में ट्वाइस तो मैं कैलकुलेट करता हूँ वेफेडर को, उसमें इशू
So
नहीं
the
है,
inlet
वेफेडर
spillage,
तो
is that
ओके।
any happening?
नो 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 स्प्लेज।
अगर इनलेट स्पिलेज का क्या होगा ना नरेश जी कि इट विल
सक्शन
बी
टंकी बोल रहा है ना।
कंट्रोल्ड विद द मिल सक्शन फैन।
तो
यहाँ पे
वेलोसिटी इसकी 0.9 है।
हाँ 0.9 मिल एक्रोमिल के अक्रॉस नहीं, तो दैट इज ओके। व्हाट यू हैव टू सी हाउ यू कैन ऑप्टिमाइज योर मिल बॉल चार्ज राइट नाउ एज स्टार्टर्स, एंड सेकंड सो दैट इट कैन डू अ फाइनर ग्राइंडिंग। आपका सेकंड चैम्बर को आप थोड़ा सा ऑप्टिमाइज करिए। Second thing is you can also check the bypass of your separator. ये दो चीजें करके देखिए, पहले बाईपास चेक कर लीजिए। बाईपास चेक आपका अगर सही आ रहा है तो आपने बताया 16% एट 45 माइक्रोन एट द प्रोडक्ट, वो भी थोड़ा
यस
ज्यादा
प्रोजेक्ट।
है ना,
यस
वो भी
पर
अभी
ज्यादा
क्या
है।
हुआ
बाईपास
सर?
के लिए इनको ट्रॉम कर बनाना पड़ेगा ना।
हाँ मैं वही बता रहा था ना कि सेपरेटर बैलेंस लेने के लिए दैट वाज आई वाज टॉकिंग अबाउट कि अगर आप सेपरेटर बैलेंस ले रहे हो ना, जस्ट टेक अ सेपरेटर बैलेंस, टेक द रेसिड्यू एट 45, 63, 90 and 212 and put it in a Excel sheet which can draw you a separate trump curve. मतलब अभी there are on the internet also you'll find a lot of Excel sheets which can do a trump curve analysis. नहीं है तो I can share as well. तो यू विल गेट टू अंडरस्टैंड योर imperfection एंड acuity, ठीक है, उसके बेसिस पे। एंड बाईपास
सर कैन यू शेयर एक्सेल शीट फॉर दिस कैलकुलेशन?
हाँ मैं कर दूँ, आई विल डू दैट, आई विल डू दैट।
ओके, थैंक यू सर।
बट आपका ना सिर्फ सेपरेटर से फिक्स नहीं होगा, ठीक है। टू फिक्स द करंट सिचुएशन राइट अवे यू विल हैव टू ऑप्टिमाइज योर बॉल चार्ज इन सेकंड चैम्बर। दैट्स बिकॉज
सर
आप सेपरेटर का, चलो आपने मान लिया, आपने सेपरेटर का ट्रम्प निकाल लिया, आपका बाईपास ज्यादा है, ठीक
यस
है।
सर।
आप सील को फिक्स
सर
करोगे।
steel around sir 8 mm around sir, 8 mm around sir, steel check 8 mm sir.
कंसिडरिंग यू विल गो बैक टू योर डिजाइन पैरामीटर, ठीक है। मान लो 9 mm 10 mm 12 mm का होगा वो, बट उससे भी आपका जो रेसिड्यू है उस वो नहीं बढ़ेगा। रेसिड्यू इज ऑलमोस्ट लाइक इन लेट्स से इन आवर मार्केट वी मेंटेन अ रेसिड्यू ऑफ 8% एट 45 माइक्रोन ऑन एन एवरेज। तो 8% से एक जगह आप 16 कर रहे हो, तो मेरे हिसाब से तो आप डबल कर रहे हो
Actually, okay, sir,
रादर।
in my, as per quality requirement, PVC we required 14 to
अच्छा
16.
सॉरी, यू आर डूइंग पीपीसी।
Yes, sir,
फिर
yes, sir.
ठीक। नहीं बट पीपीसी में तो आपका और कम होना चाहिए ना यार, 12 के आसपास होना चाहिए।
Sir, problem sir, as per quality requirement 14 to 16, sir.
चलो ठीक है, मिल रहा है, बढ़िया है, और क्या स्ट्रेंथ आ
सर
रही
मेरे
है।
को लगता
कोशिश
है सर, सर मुझे
मेरा
लग रहा
कोशिश
है कि जो
सिंपल।
सेपरेटर में फीड डिस्ट्रीब्यूशन हो रहा है वो
हाँ
प्रॉपर नहीं हो रहा है, मतलब इवनली नहीं हो रहा है फीड डिस्ट्रीब्यूशन सेपरेटर में जो हो रहा है। तो क्या है, मटेरियल जो है एक साइड में ज्यादा आ रहा है, वो सर्ज हो के बाईपास हो रहा है सर। ऐसा एक केस हुआ था हमारे साथ में। तो हमारे पास ओ सेपा का सेपरेटर था सर, तो उसमें 2 पॉइंट थे। तो वन साइड में एयर स्लाइड जाम था, कोटिंग वोटिंग लग गया था, और एक साइड में पूरा मटेरियल रस हो रहा था। उसमें भी सेम केस हुआ था, तो हम लोगों ने उसको आइडेंटिफाई किया था सर।
नहीं, मेरे इसमें भी चार चार फिटिंग पॉइंट है, तो चारों मैंने क्लीन करा, सब क्लियर है। इसमें चार फिटिंग पॉइंट है मेरे यहाँ उस सब में, तो चार फिटिंग पॉइंट में
सर
सब क्लियर है।
मैं एक चीज ऐड करना चाहता
ठीक
हूँ
है
सर।
रोहित जी, मेरे सर सजेशन की यू टू ट्राई टू मेक ट्रॉम्पर एंड कि how much bypass percentage we are getting, then we have to see the next session we can discuss further on this
ओके,
ना।
ओके, ओके, थैंक यू सर।
So one
फ्रॉम
more question from Kumar Amit. Hi Samit sir, I wanted to know when we hit a ball mill circuit for complete audit, should not we start from separator, because in most of the cases we see that separator itself is out of the order including the fan.
yeah I can see that separator.
Hmm.
You can start with the separator, मतलब I honestly I don't have an inclination about any equipment, ball mill से चालू करो, separator से चालू करो। The thing is, no, when you are doing an audit, when you're starting an audit, you also have to understand what is your most actionable equipment. You can always check any which way we are starting with the separator. We are collecting the circuit sample. We are collecting the separator balance. We will put a PSD and all those things. But how fast it will be for you to do an action on the separator rather than to do and take an action on the ball charge? Which is easier for you? That depends. If you can take an action on the separator like this, then, but again, when you're taking an action on the separator, there are a lot of, you have to understand there is a rotor, there is a cage, there's a moving cage, there's a static cage, there's the spreader, as Mr. Rohit was telling, or I think Ravi Shankar was telling. Do you have the expertise to fix all those things if there's something wrong with it? Let's say your bypass is way out of the line. How do you fix it? That expertise should be there. Separator is out of balance in almost 60% cases. But you need to also understand that it's not easy to, fix it. आप क्या करोगे? Seal कर लोगे? I'm talking about your in-house team. I'm not talking that you call someone from Christian Pfeiffer or SEPA and, or FLS and ask them to fix it. But in-house team can only do so much in a separator as compared to what they can do in a ball mill. And also understand one thing, it's a grinding circuit, it's not a separating circuit. That's why I made a lot of emphasis on the objectives. We need to understand that it's a grinding circuit, it's a grinding action. So the best course of action is to fix your grinding first. Once you have fixed your grinding, everything will fall in place. If it is not falling in place, then you go and start attending the back filter, you start attending the separator, you start attending the mixer. I have also came across plants in which everything was perfect. Everything was perfect. We did the audit with ball mill, we fixed the ball mill, we fixed the everything was perfect. The thing that was screwed was how the material was coming out of back filter. So what they did is, instead of doing a zigzag purging in the main back filter, they started doing 1, 2, 3, 4, 5, 6, 7, 8. And the plant itself was next to a sea, so it had moisture in the air. The humidity was high, and the material started lumping. There is a moisture in the compressed air, there is a moisture in the air, and there is a temperature difference. The material started lumping. They were not having enough fines. They were having enough fines technically. Theoretically, the fines were perfect. But when it was coming out of back filter, it was not the case. So that's why I say we can find faults everywhere, but we have to see which is the actionable point first. Mr. Amit, does that answer? Perfect. Any other question, guys?
Anyone can further ask, otherwise we have to maybe in the next Saturday we will discuss the second part of this, the how to design the grinding media, and maybe I think sir has to take one more session regarding the liners part, regarding the mechanical inspection also, because two three things we have to keep in mind ki mechanical plus process audit is a complete audit of the ball mill. So first
Yes,
of all,
sir.
really thankful for Samir sir for giving the time to us. And my humble request to all of the participants, kindly ask the maximum questions, take the advantage of these opportunities, because these session we are conducting free, only free, and because what we are doing, what we learned in our life till our my experience around 15 years, her experience around 16 years, we are sharing our knowledge. So better to utilize, especially for the youngers who have only experienced 4 years, 5 years, those who wants to learn this cement grinding and this cement plant, they can ask so many questions. Okay, so anyone, otherwise we have to close the session.
Sir, I have one
Thank you, sir.
question.
Yeah.
These headers, what are the reason get damaged? It may due to the installation or the metallurgy issues or in the maximum filling percentage of the joining media. So due to that, it is damaging or what? Let me know.
Mostly the filling percentage, because I will consider that your supplier was honest enough to give you the right material, and obviously the supplier of mill was sound enough to give the right ball charge, ball design, ball mill design. Most of the time, if your first chamber is overfilled, or is if it is not overfilled, but if it is expanded, the balls will be hitting the header and it will cause the breakage.
Okay, anything else the session? Okay, I think we have to close the session. Thank you, sir, so much again, once again. Thanks to all the participants.
Thank you,
Thanks again.
guys.
Next Saturday, we'll meet again with the part two with the ball mill optimization. Okay, thank you. Thank you so much, sir.
Thank you.
Thank
Thank
you,
you,
bro.
sir.
Thank you. Ciao. Bye bye.